Hello, this is Mark from Control Devices. I'm just here to show you a little bit more about the SLS sensor. Now what you can see here is an SLS095. The technology is exactly the same as the SLS095, the SLS 320s, 130s or the MLS. So essentially what it is a linear potentiometer. As you displace it, you get a variable voltage. Now you need to make sure that obviously your red wire is connected to your positive, your black wire is to the negative, and your yellow wire is the output. You shouldn't short these two, red and yellow, together and make it to a variable resistor. That's going to damage the sensor. So what I would say is always make sure that you have three wires connected. Obviously that goes to your device. Now the linearity will certainly depend on the input impedance of this circuit where it actually goes into. Right here it's actually going back to the voltmeter, so I have at least 1 meg of input impedance, so you get a very nice linear output. Now below here we've got 12 volts, as you can see, active going to the sensor, and what I'll do is just zoom in here so you can possibly see the fine detail when I move it. So as you can see, just slight bits of movement will give you a variation in the voltage. So as I pull it all the way out, it goes to almost 0 volts, all the way in to 12. Okay. Now the little dead band sections about the beginning of the stroke and the end of the stroke. Now you can actually move this sensor just ever so slightly down. It's about 1 millimeter or so. So I'm just pushing it in. Oh, there it is there. Probably pushed it too far. This is where it begins, actual stroke. So you can see I'm just going to grab it, and you can see I can pull it out a little bit. Now nothing really happens at that point, okay, just before that. Now all it is just a little bit of extra mechanical space for you to set up so you don't overstroke the sensor and pull this out. That's why you've got that little bit of play in there, like this, what we call dead band. Now also there is dead band, as you can see I'm moving that up and down. There's not much real change, but the real change happens when it finally hits it there. See, so there's the change, and you can see I can push it further in. So you've got a little bit of stroke there that is actually not being measured, but the difference, the actual stroke from here to here is 50 millimeters where it's actually active. So that's the way this actual system has been designed, this actual sensor. So if you have one other little thing, let's just move to 6 volts, which is basically the middle of the stroke. So you've got this, okay, let's call that at the middle of the stroke. Now the problem is you need to have a good power supply, because what I'll do is I'll actually go to my power supply output, and I will move it to, let's just say, the middle section there. And what I'll do is I'll actually vary that, so I'm going to turn that down. As you can see, the actual output will start to drop. Okay, so I'll just move that back to 12. Now watch what happens. I'm going to turn that output down, and you can see that without even moving the sensor, so the actual output will vary. So you know, you can move it up or down, and it will actually affect your sensor. So it's very crucial that your power supply is very stable, or else you're going to get you know, false measurements. So I would suggest that you have a very good voltage regulator. Here I've got a lab power supply powering it, so you can see there, without moving I could do it. So obviously that's going to affect it. So that's at full stroke. Now if I drop this down to, just say, let's just call that 11 volts at full stroke, look at that, it's going to be 11 volts. So whatever you apply to the red wire will be its maximum stroke. So even if I did this, you know, let's go down to 7 volts, it's all the same. You know, at maximum stroke it'll go from 0 volts to 7 volts to the applied voltage. I hope that helps a little bit. If you have any questions, please let us know.